Alright guys, welcome to the final tutorial of chapter 2, tutorial 6, input layout and viewport. We're almost there guys, we're almost there. What we need now is to define how our data kind of link from the vertex buffer to the shader. Alright, so let's define something else. We can close our pixel shader here, we don't need that anymore. Let's add a fourth member here. Interface Direct3D11 input layout. Input layout and initialize to null. And again, right away, first thing you should do, release it. Okay. Okay, so we're going to actually load the layout into the create shader function. Because it's kind of related anyway. So remember, we were loading files, we were loading the data from them and creating our pixel and vertex shader. Now we need to create our input layouts. All right. So this is only like 2 lines of code, it's not too bad. So the first thing we need, as usual, we need a description in DirectX. We kind of need that for almost everything. Input element description. Layout is actually an array. Alright, so remember, so I will open my vertex shader again. Remember, we had actually 2 elements there. Alright, so we had a position and we had a color. So we kind of need to define this. So this is called an input element, and we have 2 of them. Alright, so let's put equal there. So the first one, we marked it as position. All right, so remember we've put position here. This kind of an int. This is not just random stuff, like you cannot just put whatever name you want there. It has to be one of the things understood by video cards. There's a bunch of them. We will see more as we grow into more tutorials. Right now we saw position and color. Second parameter, you can just leave to 0. It's basically you can have more than one color, and you know, if you have a second color, you can put 1, 2. So we will see that later in the future. All right. So and then the next parameter is the format. So DirectX graphic infrastructure format. Remember, we used that in the past. And what's our format here? It's actually 2 floats. All right, so one float is 32 bits. So it's basically you want red 32 and green 32. All right, everything is kind in the format is kind of described as a color. But you know, this could be like X and Y. It's just this doesn't exist. Everything in the format is defined as a RGBA component. All right, just so we don't create multiple definition, but that's basically, it's 2 floats. All right, let's just see it this way. The next parameter is going to be 0 again, and then the parameter that follows is what's the offset. So this is the first element, so it's going to be 0 again. No, wait, I think I've skipped something. Yeah, no, 0, 0. Okay, and then the next parameter, it's going to say, well, what is this, right? What is this? This is vertex data. So Direct3D11 input per vertex data. Again, I don't know why they need this, because when you set up the layout, it's pretty obvious. Oh yeah, actually you can set up layouts for multiple shader stage, like there's tessellation and stuff. So I can understand why they want you to specify. Just always puts this. All right. And then the next one is you can ignore it, 0. All right, so that's our first one, comma. You want to define the second one because we have 2. Remember, position and color. So really, this is a little bit complicated, but you need this. You need this to bridge your data to your vertex shader, basically. Even though it should know by the look at this here, like it should know what it is when it loads the shader. So I think it's a step they should probably remove from DirectX. I don't think you need that, but it's there and you have to do it. All right, the next one, it's a color. Then it's R, G, and B, 32 bits each, right? Then the 0 there was actually the offset from the beginning. All right, so technically this is 4 byte, this is 4 byte, so it's 8 byte offset from the beginning of the vertex. So you can put 8, and whatever you add after, you kind of have to increment, or you can use a useful constant here. So Direct3D11 append align element. So this will do this dirty job for you inside. So you can, so the first one you put 0, and all the ones you have after you just put this. All right, that's the only thing you have to remember. All right, so we have defined our layout. So now we want to create our our layout object there. All right, so we go get our device, and we're going to create an input layout. Okay, first parameter is our array of layout. How many we have? We have 2. Then they want again our vertex data. You know, remember we passed the data in the size, just put that again there. And then a pointer on our input layout. All right. Why they want this there? They kind of want to validate that what you've defined there actually match the vertex shader. And this is something that the community doesn't really agree about. What I've seen some posts on this, I don't agree with too. Like this should just be like this. Because your layout can be used on multiple shaders, right? I can create another shaders that accept the exact same layout, and I will just reuse that object that I just created there. So why do I have to actually know about that vertex shader? And this is why I'm actually doing this in the same function instead of creating another function, because I need the raw data that I just loaded from the file to do this. And this is stupid. Okay, I think it's stupid, and you should not have to do this. And this is why your layout kind of have to be created and be aware of the data. Yeah, it just makes your engine design a little bit more complicated, and doesn't have to be. But, you know, that's how it is, and maybe in DirectX 12 they fixed that, maybe, hopefully. And you don't have to do that anymore. That would be wonderful. So that's how you create a layout. It wasn't hard, right? It's 2 lines of code. Well, there's more than 1 line of code, but it's considered 1. Okay, so now that we have this, again, here, we're going to bind our layout. All right, let's do it first. All right, let's get our device context and input assembler. So this is part of the first stage. Set input layout. Nope, not index buffer. I said input layout. And you just pass your layout. That's it. This one is actually simpler than the other. There's no useless parameters. All right. Quickly before we actually continue, this is ugly. I have this everywhere. Let's just get it at the beginning of the function. This is good practice. I'm trying to teach you some good practice while I'm doing these tutorials, so you don't have to kind of repeat a long code every time. Alright, so that's how we render a triangle. We set the input layouts, we set its vertex shader, we set its pixel shader, we bind the vertex buffer, and then we do the actual draw call. But again, if everything you render, like I take my Call of Duty example again, all the characters in Call of Duty are probably going to use the same vertex and pixel shader because they have the same material, right? And you can bind different texture after that here to your vertex shader. So you just do that once, and if they all use the same mesh, you can just do that once, and then you just do multiple draw calls with different parameters like matrix and stuff like that. All right, so that's how you render. So if you run this, it's not going to display the triangle, yes. triangle yet. There's one last little thing to do. All right, and it's to set up the viewport. So right now the viewport is probably default to 0, 0. So where it's actually rendering the triangle, it's probably here, like in the corner. Like if I was zooming there, there's probably like a little pixel there that we don't see. So we need to set up the viewport. So I can just go into my renderer. Let's close this, I don't need it anymore. And we're going to do that in our begin frame. All right, so remember we were claiming the buffer. Oh, let's bind the viewport before, and then we're going to set the viewport. All right, how you do this? You create a new viewport using an ND function called C constrict a new D3D11 underscore viewport. And there's basically a couple of parameters in there. You only care about the first one. So top left, well, it's going to be 0. Top left Y, that's going to be 0. And then the width and the height, right? So we already know the window is 600 by 800. And they want dues to be floats, so don't forget to put the little F, otherwise it's going to be red. And so we created a new viewport, and then we just set that to our device context. All right, so we're going to do RS set viewport. RS stands for rasterizer stage. Right, this is where it's actually clipping the things against the viewport. And we're going to say we have one viewport, and we're going to pass a pointer on our viewport, which is basically an array because you can have multiple ones. I haven't tested it. You can try having an array of multiple viewport and what the result of this. All right, so now if I run this, we're going to see a triangle. No, it doesn't work. All right, why? Why? Why it doesn't work? Oh, I know why. All right, so we kind of missed a step here. This is cool because I'm doing little mistakes, and you can see why you can actually like pull your hair and try to render your first triangle. Bind the render target. I'm not sure why it actually worked previously. No, actually it didn't work. We were just clearing it, but we were not actually rendering the triangle to it. So you have to bind it. So let's go get the device context and say OM for what's OM stands for already again. Let's go quickly there. Output merger. Yeah, okay, so yeah, so basically at the end where you're going to render those pixels, well, set render target. All right, wait, what am I doing wrong here? OM set render targets. Okay, I guess it took a S at the end. So how many we set? We can render multiple ones. Let's say you, during different rendering, you're going to probably bind around 3, 4, 6 of them. We just have one right now. All right, and you just pass basically a pointer on this one. Again, the reason it's a pointer is because it can be an array. And the last parameter is the depth buffer that we're going to see in further tutorials. So just pass null for now. This last one is going to be used when we do 3D. So in 2 chapters. So the next chapter is going to be 2D. We're never going to use that. All right, now that it's bound, crossing fingers, we shall see a triangle. Yay, we see a triangle. All right, so that was about 4 hours of tutorials just to get to this. I hope you're happy, and you can see it's beautiful gradient. So we set a different color on each vertices, and it's beautifully, interpolating between them. So you'll notice something quickly there, that because we're not done yet. All right, we didn't set the viewport correctly. The the corner here at the bottom, it doesn't actually on the corner, and here also. This one's at the top, this one's fine. This is because we set the viewport at 800 by 600, but the view here is actually a little bit smaller, right? So 600 here actually arrived a little bit down there. Why? Because when we created the window, the top bar there and the little bar on the side there actually are part of the 800 by 600. So you're actually rendering less than this, right? So what you want to do is actually query what's going to be the size. Like we have the back buffer here. We can actually go get more information about it and know what's the real size. And we're going to use that for rendering a bunch of things. So so let's go get it. So this is basically a DirectX11 texture 2D descriptor. All right, let's call it back buffer description. Notice that it is not a pointer here. It is just a plain object. And let's go here before we actually release it. And then let's go get this. So we got our back buffer and say get description and get a pointer on it. All right, so we're going to set a breakpoint here. I'm going to run this just so you can see what got filled in there. So you can see the actual resolution there. It's actually 784, not quite 800, and 562, not quite 600. And you can see other nice information there about like the format and the quality of the sample, basically stuff that we have set up there in our swap chain. Except the resolution that we have set, well, we have not set resolution there. It took the resolution of the windows that you pass here. So this is wonderful. So now that we have that information, we can actually use this directly. So those are integers. So you want to cast them into float, so it doesn't complain when you compile. All right, and now our triangle actually goes directly into the corners, and it's beautiful. All right, so that's basically the end of our chapter 2. Let me show you because you worked hard for it, so I will leave it longer on the screen. So this ends our chapter 2. Those full tutorials are about 3 hours total. It's kind of long just to get to this, but I've explained pretty in depth a lot of things in the way, so those explanations can get useful to you in the future. Okay, next chapter we're going to see quickly how to basically do a small timer. So when you animate stuff, it's going to animate smoothly. We're going to see inputs with the controller, Xbox 360 controller. It's probably going to work with the Xbox One controller too, but I don't have one, so I can't test that. And then we're going to render sprites using textures, not just triangle, but maybe little hero walking around. Like we can continue the little RPG we kind of started. And we're going to create a sprite batch. So those that did XNA knows about the sprite batch. Unity kind of uses sprite batch too internally. So basically it's a more efficient way of rendering a lot of sprites on the screen. This is going to be the foundation of everything you're going to do in 2D. So it's important we do probably one of the first tutorial. It's going to be a little bit more complicated, but we need this. All right, so you can play a little bit there, add more vertices to it, maybe try to do a circle and try to do a square and whatever. Just play with it. You get some practices how to actually have different amount there, and you don't forget to change the number you draw there, and you can play with the shader a little bit. If you want, you can just output red, like I said previously, and the whole triangle will be red. Try to do stuff. Try to modify the vertices also. Experiment a little bit before switching into the next tutorial, the next chapter, because it's going to be a little bit more AV, but we did the most AV part so far. The rest is basically just maths and loading a texture, and now that we know what a device context is and all, it kind of gets easier, and we have actually see things on screen, so we don't have to pull our hair so much trying to get things work. All right, so our class grown a little bit, but it's still not too much code. All right, hope you enjoyed, and see you in the next chapter. Thanks for watching.